Hello everybody, so today I will be explaining to you on how do we solve question number 1 of our Lepak Marvel chapter 3. So this figure has two blocks and one of it is on a smooth horizontal surface. It is connected by a thin cord that passes over a pulley to the second block which hangs vertically. So we have to draw the free body diagram for each of this block. So I would start by listing down what are the forces that we have learned in this chapter. First, we have what chapter? So first we have weight, which is equal to mg. Next, we have normal force that is only present when there are two surfaces that is in contact lah. Next, we have the friction force, which is only present when there is a rough surface and the direction is going against the motion. Next, we have the external force. It can either be a push ataupun pull forces. And lastly, we have tension, when there is a rope, there would be tension. Okay, so the tension punya direction, it is always gonna be going away from the object along the rope. So let's start by looking at object A first. All right, I would just say it. I label it as object A je lah. Okay, so first we would have both the normal and weight force. Next, since there is a rope here, there would be a tension. Okay, so tension tu di sini lah, tapi because we want to simplify our free body diagram, we would just draw it at the origin. So this is your free body diagram for block A. Just draw a dot representing the object. So this is MAG. This is your tension. This is your normal force. Next, let's look at what is being experienced by block B here. So first, we know that this has weight because it is not negligible. So we are gonna draw a downward arrow. Next, we have the tension here. So it is gonna be going away from the object along the rope. So that is your tension. And that is your object lah. The dot is representing your object. So this is your tension. This is your weight. Okay. Alright, so that is your free body diagram. So if you get all correct for these forces, you will get full mark, which is 3 marks lah. 3 marks macam 3 marks. Yeah. Okay. So what you need to know from this is, for the free body diagram, only draw what is being experienced by the object. So these are the forces that you need to check lah, whether it is present ataupun tidak, whether the object is experiencing it ataupun tidak. Okay, macam tu je. So now let's look at question B, where we need to determine the acceleration of each block, and the mass of each block is given here. So for this case, what I would do first is write down the equation for each block. Tapi it depends on what is needed juga lah. Alright, so for block A, we need to apply Newton's second law of motion lah. So let's look at block A dulu. So total force in the x component is equal to mass of block A times acceleration. Okay, for this one, for the sign convention, I would suggest you to follow this sign convention lah. So anything that follows the direction of acceleration, so assuming the acceleration is pointing to the right and going down, so this is your direction of acceleration. So anything that follows the direction of acceleration, we would put it as positive. Okay, so sekarang ni, if we look at this here, tension is following the direction of acceleration, so it will be positive. So T will be positive, T equal to MAA. So this is your first equation. Next, do we need to look at the y component? I don't think so, because we do not need the value of n. So n is usually needed when the surface is rough, when there is a presence of friction, where friction is equal to mu n. Okay, di sini barulah kita perlu cari value of n. But in this case, we don't need the value of n because we only have tension present in the x component. Next, let's look at block B. Okay, for block B pula, we are going to look only at the y component. Why do we look at the y component only? Because we do not have anything in the horizontal component. Okay, so other than that, the movement is also in the y component. So mestilah kita tengok the component that has motion. Okay, sebab kita cari acceleration. So total force in the y component is equal to mb A. So untuk y component, since the weight is following the direction of acceleration, it will be positive. So mbg will be minus 3 lah. We'll subtract 3 pula. So this is going to be mbg minus t equal to mba. So this is your second equation. So since they are two unknowns, which is the tension and the acceleration, you would usually need two equations in order to solve the question, because kamu perlu buat simultaneous equation lah. Alright, so now this is where we are gonna apply maths sudah. Your physics is done because the concept is for physics, and then now we have to understand, we have to do the maths lah. We have to do the maths carefully supaya kita tidak do any careless mistake. So now we can substitute equation 1 into equation 2. So it will become mbg minus maa equal mba. So now kita bawa a ni pergi sebelah kiri supaya we dapat mba plus maa equal to mbg. Okay, so we factorize a. So mb plus ma equal to mbg. So acceleration is equal to mb plus ma. So this is mbg. Okay, so substitute all the values. You should get, this is 5, this is 9.81, mb is 5 plus 13 kilogram. So you will then get the acceleration to be equal to 2.73 meter per second. Okay, so that is the acceleration for both block. They should have the same acceleration lah. Okay, next, for question C, we have to apply chapter 2. Okay, so always remember in PSPM, you will be applying a few formulas from other chapters to solve one question juga. Okay, so it doesn't necessarily mean one chapter ikut semua chapter 2 punya formula je. Tidak, okay? So it will macam mana? It will use both. I mean, it will use other chapters punya formula lah. Okay? Okay, cukuplah bercakap. Now, question C pula, we have to determine the time taken to reach the edge of the table. So I would do C di sini lah. So this one, we are going to apply the formula S equal to UT plus half AT square. Kenapa kita boleh guna ni? Sebab the acceleration here is constant. Okay, so since the acceleration is constant, we will then apply this equation here. So now S is given, which is equal to 1.25, and then the block is initially at rest, so equal to 0. Acceleration is the one that we've calculated just now, which is 2.73 meter per second square. Oops, I did something wrongly. This one here, it should be meter per second square, sorry. So dari situ barulah kita boleh substitute all the values so that we can solve for t. Okay, so dari sini t will be equal to 1.365. T squared equal to 1.25. So rearrange that. We'll get 1.25 over 1.365. So time is equal to 0.957 seconds. Okay, so that is how you solve for question C. So for question C, maksud dia di sini ni, dia sudah cakap dia at rest lah. Then dia cakap 1.25 meter from the edge of the table. So the distance is actually from here to here. Okay, so it is not from dari sini ya, dia bukan dari situ. It is just this distance here. So this distance here is our value of S lah, which is equal to 1.25 tadi. Okay, this is the solution for question number 1.